welcome back.
Hi everybody, welcome back. We're on Fundamental Identities Day 2.
Day 2.
Day 2. We got a couple more strategies for you and a little bit more with the proving.
But the good news, there's no more new identities.
Oh, yes.
We have all the same ones we had last time. We just have another day to work with them and some other processes and algebraic techniques to attack problems with.
Yep, we just got to remind you of a couple techniques.
Very good.
You're on.
I'm on? All right. So, first things first, fractions. Everybody's most favorite things in the world. We got proofs and we got fractions. We're going to put them together into one big giant thing.
Great.
I can hear the moaning. All right. Least common denominator. If we want a least common denominator, we have to, or in order to add fractions, we need a least common denominator. So, how are we going to find that? Well, we have a 1 minus cosine of x, and when you have a plus or a minus, those need to be grouped together as a factor by themselves. So you have 1 minus cosine of x as a factor, and 1 plus cosine of x as a factor. So what's the least common denominator of this going to be?
Well, they don't kind of go into each other, so we're going to have to use both of those factors. So how about 1 minus cosine of x times 1 plus cosine of x?
Okay. And earlier in the year when we had equations, we were able to multiply everything through and get rid of it. We can't do that here because we have to work on one side only, and in this problem there actually is no equal sign. So we're going to have to add the fractions together. And the way we're going to do this is we're going to take the original problem, 1 over 1 minus cosine of x, plus 1 over 1 plus cosine of x.
And notice the amount of room Mr. Lecky's leaving right here.
And we're going to make sure that both denominators have a 1 minus cosine x and a 1 plus cosine x in it. So we're going to multiply the bottom of this one by 1 plus cosine x. And if I multiply the bottom of a fraction, I have to multiply the top by the same thing.
That way we're just multiplying by 1.
Anytime you multiply by 1, you don't change anything. We're just changing the way it looks. So we're going to do the same thing over here, except for this one had a 1 plus cosine of x in it. So we need a 1 minus cosine of x on the bottom and on the top.
So we're making sure that each fraction has all the pieces in the least common denominator.
So here's my least common denominator. I have the same one in both fractions. So I can literally write this with one fraction as 1 minus cosine of x times 1 plus cosine of x. And now all I have to do is take care of the numerators. And the numerators are going to be 1 times this plus 1 times that. Okay? So we could write that down, or we could go ahead and distribute the 1 right off the bat. 1 times this is just going to be 1 plus cosine of x. I have a plus 1 that's multiplied by 1 and minus cosine of x, so I get plus 1 minus cosine of x.
Okay, so now we have one fraction instead of 2.
Yep.
Great.
Now we just need to clean it up.
Okay.
So we have 1 plus 1
is 2.
Is 2, and plus cosine x minus cosine x
those just cancel, those are 0.
Gone. So here's what we have. We have a 2 on the top, and on the denominator, we have 1 minus cosine x times 1 plus cosine x. Any idea what that might be?
That's 1 minus cosine squared of x.
That is 1 minus cosine squared. If you don't believe me, you could FOIL it out. Okay, but those middle terms are going to cancel. That's just the difference of 2 squares. That's going to come back later.
Don't we have an identity for 1 minus cosine squared?
We do. 1 minus cosine squared. Let's go back up here. How about over here? We had sine squared of x plus cosine squared of x equaled 1 from the first part of the day yesterday or last class. So if we subtract the cosine squared to the other side,
that's really just a sine squared.
1 minus cosine squared is just sine squared.
Remember those Pythagoreans you can use in any of the 3 orders.
So this is 2 over sine squared of x, and the reciprocal of sine is?
Cosecant.
So this can be written as 2 cosecant squared of x. And there's our one single term that we're always aiming for when we're simplifying this.
Much nicer than 2 fractions.
Much, much nicer. That whole messy fraction thing is only just 2 cosecant squared of x. Piece of cake, huh?
Great.
All right. Try another one?
So they should probably try this on their own and pause the video.
They should. Pause the video, try it on your own, see how it works. Should I go ahead and do this one too?
Yep.
All right, I'll stick with the fractions. This time we have a sine of x and a cosine of x. We'd like the least common denominator to have both of those involved. So we're just going to multiply them together. So what is this first fraction missing?
It's missing a cosine of x.
We have secant of x over sine of x minus sine of x over cosine of x. And we're going to multiply the top and the bottom by cosine of x.
Okay.
And how about the second one?
It's missing a sine of x.
So I'm going to multiply the top and the bottom by sine of x. And I'm going to have now a common denominator of sine of x, cosine of x. So I'm going to make one fraction with that denominator. And all I have to do is clean up the numerator, which is going to be all of this minus all of that.
Okay.
Well, what is secant of x times cosine of x?
Well, aren't those reciprocals? reciprocals?
They are.
So a number times its reciprocal is 1.
Always. So this is going to make 1.
Okay?
Then I have a minus sign,
Okay?
and I have sine of x times sine of x, which is
Sine squared of x.
sine squared of x. And hopefully by now you're starting to realize that that numerator is a Pythagorean identity.
It is. It's cosine squared.
That is just cosine squared of x. And if, again, you're not clear on that, look at the last example, or first thing you do when you walk into class tomorrow, come talk to us. But that's what the numerator is going to be. The denominator is still sine of x times cosine of x. But what can we do now that we have one single term in the numerator?
Oh, and we don't have any adding or subtracting, so we can cancel.
All multiplying and dividing means you get to cancel like terms. So cosine of x cancels with one of those.
So it's cosine x over sine x?
It's cosine x over sine x. And what is cosine x over sine x?
Cosine x over sine x is cotangent.
Awesome.
Much nicer.
One single term, piece of cake. All right?
Don't
You're
you
up.
wish you could have Mr. Lecky come do all your fractions for you? Okay, another topic we need to talk about is, come over here and use your highlighter. We're going to talk about factoring. Now, we talked about factoring last class, last video, but this is factoring with the difference of squares. So just real quickly, let's remind ourselves. When we have something where we have a factor like a plus b and a factor times a minus b, we used this in a couple examples ago. Very quickly, we knew that was a squared minus b squared. Again, if you don't believe us, spoil it out. What we want to be able to do is go backwards. Sometimes when you see things squared, you think Pythagorean identities, and sometimes when you think things squared or see things squared, you want to think of a plus b times a minus b. So when we take a look at this one, number 9, we could, if we wanted to, change this numerator into sine squared.
But don't write this down. Just watch real quick.
Just watch real quick here. But if I change that into sine squared, I still have a cosine on the bottom, so I've actually made it worse, because now I have two trig functions rather than one trig function. So don't just blindly change everything to sines and cosines or blindly plug things in. Kind of look at where you're going. I have a 1 plus cosine in my denominator, and I have something squared on the top, and I see a minus right there. So this is really the difference of squares. It would be 1 plus cosine of theta, rather. Cosine of theta, we like our x's, and 1 minus the cosine of theta. Okay. Again, we still have that denominator, 1 plus the cosine of theta. Now what can we do?
Well, we have a 1 plus cosine of theta on the top and the bottom.
And even though there's a plus there, since it's an entire factor, we can cancel that entire factor. And it's very simply 1 minus the cosine of theta. Okay.
That's it?
That's it. No more fraction, no more squared. There's only one trig function and an extra 1. Okay? So let's take a look, try another one here.
Well, they picked the right thing to do first. That wasn't too bad.
It was a lot easier, wasn't it? Nothing like canceling. Okay. Again, pause the video, give it a try. Come on back with us when you're ready. Okay, so this time I see a secant x plus 1, and I see a tangent squared. Again, I have two different trig functions. Tangent squared. Talk to me.
Well, 1 plus tangent squared is secant squared because I get a tan in a second.
Yes, you do. I do not, but you do. Okay? I don't have a 1. I just have a tangent squared. So if I could solve this, then I would have the tangent squared of x equals the secant squared of x minus 1. Okay? That, my friends, is a difference of squares. So let's substitute that in. We've got the secant of x plus 1 over the secant squared. Now, Mr. Lecky, what's the most common mistake you see in this kind of problem?
They want to just cancel out those secants and the ones.
No. You cannot cancel when you have a big fat plus and minus right here. Don't do it. I know you want to. Don't do it. Okay?
Not allowed.
So we have to do something different. Well, we could change our secant squared back into a tangent squared, but that's not going to get us very far. Recognize we have the difference of squares. Something squared, a minus, and something squared. Okay? So we're going to change this into the secant of x plus 1 times what?
Secant of x minus 1. And those now are individual factors. That's the benefit of factoring. It takes what was added and subtracted, turns it into multiplication. And when things are multiplied and divided, I can cancel like terms.
Yes, we can.
So secant of x plus 1 just goes away and makes a 1?
Yep, makes it 1. I was just going to say what's left on top. Okay?
And when you see that minus sign in the denominator, you can't split it up. It's just secant of x minus 1. No taking it apart.
Yep, it's one big thing. So that's about as far as we can go with that one. Alrighty? So, let's take a look here.
What's up next?
Well, we covered least common denominators. We've covered some factoring. we're gonna do a little factoring with a box.
All right, you guys remember box factoring?
Come on over.
Or any other factoring method?
No,
Okay.
This one looks kind of messy.
Remember, our goal here is to simplify this as much as possible. And one of the ideas of factoring, and the first idea you learned in factoring, was to take out a greatest common factor. And we did that last class period, or
Yes.
last video. We keep saying last class. You notice there is a cosine in every one of these terms?
Oh, that's our GCF. We can
There's
take
our
out
greatest common factor.
cosine.
We're going to take a cosine of x out of the entire thing, and we get sine of the fourth of x minus 2 sine squared of x plus what?
1.
1. That's the part people always want to forget. They want to pull it out. You're dividing out the cosine because you're undistributing, so make sure there's a 1 at the end of it. Okay.
Remember, you can always check it with distributive property too.
That's right. Okay, now, here's where we got to go. We're going to try to simplify this a little bit further. Now, we need to learn to recognize this as being factorable in the first place. Does that make sense? If we had written, say, a squared minus 2a plus 1, most of you are going to be able to get to here without too much of a problem.
Right.
What I want you to notice is that this term is simply the square of that term. And so if I write this as, let's pick a different letter. How about
Y.
Y, is that good enough? Y to the fourth minus 2y squared plus 1. We can apply our same factoring techniques because the first term is just the squared version of that middle term. And everything we did with the box and factoring will still work.
Okay.
So why don't we, for a moment, focus in on this y to the fourth thing here. All right, let's try that. In this problem, y would be equivalent to sine of x. Is that okay?
Yes.
So you can make that change in your head if it's easier for you, or you could do the whole box with sine of x's in it. What we're going to do is we're going to make our box like we did when we first learned how to factor.
Okay, so we've got y to the fourth in the first corner.
Y to the fourth in the first corner.
And a plus 1.
There we go. And we have an a, c, and b is what we're looking for, yes?
So two things that multiply to be 1.
So we have 1 times 1 is 1, and the middle number here is
Negative 2. So wouldn't that just be negative 1 times negative 1?
There we go. So negative 1 times negative 1 and negative 1 plus negative 1 make
Negative 2.
negative 2. So we're going to have a negative 1y, but this time we need a y squared.
Oh, okay.
Okay, because we want that middle term to be negative 2y squared. If we combine all the terms in our box, we want it to come out to be y to the fourth minus 2y squared plus 1.
Okay.
All right, so our first step in factoring is take out a greatest common factor of the first row.
Y
which would be
squared.
Y squared. And y squared times y squared makes y to the fourth.
Y squared times negative 1.
And y squared times negative 1 here would make negative 1y squared. And negative 1 times negative 1 makes positive 1.
Okay. But we didn't really have y's.
No, we didn't. What did we have?
We had sine of x.
We had a sine of x. So we really have here,
So would we have sine squared?
we have sine
Minus
squared
1?
instead of y squared. So it's sine squared of y
X.
minus, oops, too many letters. Sine squared of x minus 1. That would be the equivalent of this part. And then this y squared minus 1 would just be sine squared of x minus 1 as well.
Okay, and we still have a cosine
We
in
still
front of
have
it,
this
right?
little guy out in front, so don't forget about it. All right, now what is sine squared of x minus 1?
Oh, it's cosine squared.
Close.
It's not cosine squared.
We had 1 plus sine, sine squared of x plus cosine squared of x equaled 1. If we subtract
Oh, it's
this 1,
negative cosine squared.
then we got to move the cosine to the other side as well, correct?
Yes, that's negative
So
cosine squared.
this is negative cosine squared of x times, and this is the same exact thing,
Negative cosine squared x.
and this is still a cosine of x out in front, and now we've got all cosines.
Okay,
So we have cosine times cosine squared makes cosine to what power?
to the fifth.
To the fifth.
And it's positive because
Yeah,
a
but-
negative times a negative is a positive.
Negative times a negative is positive, so our answer is simply cosine to the fifth of
That's
x.
much prettier.
Yeah, especially of all this mess, huh?
Yeah.
So again, we had to factor. Now, not all of them are going to be the fourth power, but the key to this example is for you to understand that you can factor these things just like we factored polynomials.
Yes.
Using the box, as long as you have a squared term and long as this term is or squared of that term, or vice versa. I think I said
You
that
square the
backward.
middle one to get the front one.
That's what I'm trying to say.
Okay.
All right, as long as that's the case, think about the option of trying to factor it with the box, or however other methods you learned how to factor.
Okay.
All righty. I think this is the last one.
This is our last one. Okay, so far we've been doing all this kind of in the dark, simplifying it as far as we can. But remember last class we also talked about proving, which is where we started with one side and had to get all the way to the other side. So of course, we want to start with the messy side or the yuckier side. So Mr. Lucky, which side is messier?
That'd be the left side.
The left side. So we're going to start with this left-hand side, which is two fractions. And I'm going to see if I learned anything today about combining my fractions. I need a least common denominator. And those don't cancel with each other. So I'm going to use 1 plus the sine of theta times the cosine of theta as my least common denominator. Okay, so if I rewrite my fraction, where I have the cosine of theta and 1 plus the sine of theta, what am I missing in my first fraction?
A theta.
Well, that too.
How about
What am
a
I
cosine
missing?
of theta on the bottom?
Okay, I'm missing the cosine of theta on the bottom, so I'm going to times by a cosine of theta. He's so literal sometimes. The cosine of theta on the top. Okay, and then we're going to have our plus in the middle. Stretch out your fraction here. 1 plus the sine of theta was on the top, and cosine of theta was on the bottom. So this time I got all my thetas in the right place. So what am I missing from my least common denominator?
1 plus sine of theta.
Okay, and right over here we're going to put a 1 plus a sine of theta. And I need to be careful when I put that on the top because I want to make sure that I don't lose track that that's one entity. And I have a 1 plus a sine of theta right here.
So does that mean we have to FOIL the top of that fraction?
That means we're going to have to FOIL the top of that fraction.
That
But first
sounds
I'm going to
fun.
put it all over a cosine of theta times a 1 plus sine theta. Now I could distribute that, but I'm going to wait just a second to see if I'm going to need to distribute.
It's a good idea not to, just in case something cancels.
Yeah, because we like it when things cancel. Okay, so cosine times a cosine
Cosine squared
is a cosine squared.
of theta.
Thank you. And I'm not going to go through the foiling. Hopefully you can do all the foiling by yourself. So what are we going to get, Mr. Lucky?
We're going to get 1 plus 2 sine of theta plus sine squared of theta.
Yes, we are. Okay. This is all one fraction.
That looks a lot messier than it started with.
I'm losing track here. Okay, well, let's see if we can do any simplification in our numerator here. Will it go with that? There we go. Okay, I see a cosine squared plus a sine squared.
That makes 1.
That makes 1. And I already had a 1 right here.
So 1 plus 1 is
1 plus 1 is 2.
2.
So let's go 2 plus 2 sine theta.
Oh, that's almost tricky.
Oh, that's a little prettier, isn't it? Over cosine theta times 1 plus sine theta.
You know what I'm noticing?
What are you noticing?
I'm noticing there's a 2 in both of the terms at the top of that fraction.
Otherwise known as a greatest
Common.
factor.
I'm getting the urge to factor.
We love factoring. Okay. So let's take our 2 out. And conveniently, when we take our 2 out, oh, now what do you see?
I see a 1 plus sine of theta as a factor in the top and the bottom.
Yes. And if it's a factor in the top and the bottom, what do we get to do with it?
Cancel them
We
because
do
they
get to
make
cancel
1.
it. Because they make 1.
And then I got 2 over cosine of theta. What's
Okay.
2 over cosine of theta?
Well, cosine is the reciprocal of,
Secant.
so wouldn't this just be 2 secant of theta?
Is
Now
that what I
again,
wanted?
This was approved. Let's go back and see. Was that what we wanted?
I
Go
sure hope so.
way back up
Oh,
here.
phew.
Yay. Okay. So we can use all these strategies mixed up together. You can use your Pythagoreans, your cofunction, your even odd, changing to sines and cosines, combining your fractions. What else did we cover? Factoring every which way.
I
To
think it was
prove.
like 8 strategies, 7 strategies?
I
What
think
we
so.
end up with?
They have them in their notes. You have my notes.
7 strategies.
7 strategies that you can use on any of these problems. Okay? So I think that's it for lesson 2. Day 2.
That'll work.
We're calling this Identities Day 2. So
See you later.
bye, have a good day.